In this video, we'll be discussing the important topics of AIML subject second module, that is informed search strategies and ML introduction. So if you have not watched my previous video, I have explained all the important topics module wise. So as an extension to that, I'll be discussing the answers here or the important topics. So in second module, in informed search strategies, we have GFS, that is greedy best first search. So greedy best first search is, it displays the path that appears to be best at that particular moment. So right, so the actual optimal path may not be the same which the result gives in greedy best first search, but then at that particular point, whichever it finds to be the best would be selected. Okay, the order or the basis on which the selection is done is the heuristic function here. So a node is considered for expansion based on evaluation function, that is f of n, and constructed as the lost estimate, so that other node with lowest, so that the cost estimate, so that the other node with lowest cost is expand first. So here this is pretty important. F of n is equal to h of n. H of n is the cheapest cost or the estimated cost from the node n to the goal node. So as I said, greedy best first search may not give the optimal solution, but then the solution has some sort of value. So looking at the algorithm here, function best first search, we enter the node. So initialize open to the starting node. So firstly we take the open and then initialize it to the starting node. If open is empty, then return failure. If open is empty, you can't go further, right? Return failure and stop. If not, minimum value of h of n from node n placed in the closed list. This is the second step. This was the first step and this was the second step. Adding values in the closed list. And then we expand n and generate the successor. So from n, we move forward considering the path cost. Okay, minimum value of path cost. Then expand n. Yeah, this is done. If n is equal to goal state, then return closed solution. Once we reach the closed state, whatever is there in, once we read the solution, whatever is there in the closed state would be given as the output. Then else continue visiting all successor and obtained closed. So once you visit all the successors, once you reach the end point, then you can give the closed closed as an output. Here the time complexity is order of b power m. Okay. Then moving on to the A star search. So A star search is a combination of UCS and greedy BFS. So here we make use of heuristic function, that is h of n, and cost to reach n node from state n. So previously we had used f of n is equal to h of n for greedy best first search, right? Here we'll make use of f of n is equal to g of n plus h of n. So here g of n would give us the cost to reach the node, and then h of n would be the cost to get from node to the goal. Okay, so f of n is estimated cost of cheapest solution through n. So compared to greedy best first search, A star search expands less search tree and provides optimal solution faster. So looking at the algorithm, so function A star search and starting node, the starting node is present in the open list, and then if open is empty, then return failure and stop. If not, the smallest value of evaluation from f of n is equal to g of n plus h of n. The sum of this would give f of n value, right? The smallest among this would be selected. If n is the goal node, then return success and stop. Otherwise, you look into this part, that is to expand n and generate all successor nodes and put in closed. So if n is already open and closed, then it should be attached to back pointer which reflects lowest g of n value. Once the closed list is completed with all the result, with the path cost and the path followed, we generate the return list. So the time complexity here is order of b to the power d. Let's look at next. We have the 8 puzzle problem using heuristics. So we had discussed 8 puzzle problem in the first module, right? We had defined the state, goal state, problem, the goal test, and the transition sequence and all. So here we'll try to give one possible solution or one possible way to address this problem using heuristic function. So here we would be using the Manhattan or the priority function, that is also considered as a distance. So this is the initial state, and we need to reach the goal state. That is, this empty tile should come in the middle, empty tile should come in the end. Okay, so this is the goal state which we have to reach. So from the initial state, there are 3 possibilities. That is either 2 can move here, 8 can move here, or 7 can move here. I'll write it accordingly. So 158, if 2 moves here, firstly I'll write 3 space 2 and then 4, 6 and 7. Now I'll consider that 7 has moved up. Okay, so I'll write 158, 327 and 4, 6 and blank here. Next I'll consider that 8 has moved down. So I'll write 1, 5 space and then here I have 3 to 8 and 4, 6, 7. Now I'll calculate the Manhattan distance. Okay, so Manhattan distance says that, let's write all the nodes here. 1, 2, 3, 4, 5, 6, 7, 8. 8 tiles are there here, right? I'll consider this as M1. I'll consider this as M2 and this as M3, the distances. So now for calculating the M1 distance, compare the M1 box with the goal state. So check if 1 and 1 are in the same state or not. 1 and 1 are in the same position, so write 0 here. Now check 2. 2 is here and 2 is here. So in order to move the 2 from here to this position, I need to perform 2 shifts, right? First shift would be like this and the second shift would be like this. So I'll write 0 plus 2 here. For 3 is here and it has to come here. So 1, 2 and 3. So I'll write for 3, I'll get 3. And then for 4 is here and 4 is here. So one shift, if I shift up, I'll get 4 here. I'll write 1. So that is 1 shift is required. And for 5 also 1 shift is required. 5 is here. It has to come down. I'll get 5. For 6 also 1 shift is 2 shifts are required like this. Go here and then go here. So I'll get 2 shifts for 6. And for 7 also 2 shifts, 1 and 2. For 8 I would require, 8 is here, right? 1, 2 and 3. 1, 2 and 3. 3 shifts are required for 8. So if I add this, 14 I'll get. Similarly, calculating the Manhattan distance for M2. For 1 is in the same state. 2, I need to shift 2 by up 1. And then 3 is here. I need to shift 1, 2 and 3. So 3 shifts. 4, 1 go up once. 4, 5 go down once. 6 go up once. 7, 1, 2 and 3. 3 for 7. And for 8 should come here, right? So 1, 2 and 3. So this I'll get 14. And when I calculate M3, I get 0 plus 1 plus 3 plus 1 plus 1 plus 2 plus 2 plus 2. I get 12. So this M3 has the least Manhattan distance. So from M3 I can further split. So now there are 2 possibilities. Either 5 can come here or 8 can come here. So this keeps on repeating until I find this particular goal state. So that was about 8 puzzle problem using heuristics. This is not that important, but in case they ask, we should be capable to calculate the Manhattan distance at least. Next we have the greedy best first search. So in this they have given the graph here, and then here the h of n values are specified. So as we have seen greedy best first search, let's write the formula, that is f of n is equal to h of n. So in order to perform the searching, we need to consider the f of n, the h of n values, heuristic values. Okay, so whichever node has h of n as 0 would be the end or goal state. Okay, and wherever we have s would be the start state. So s is the start state here and g is the end. I need to reach g here. So in order to reach from s to g, I need to consider only the h of n values. I need not consider whatever is written here. Okay, so that is one point to remember about greedy best first search. So I'll start from s. S has h of n value 13. Then from s to a, for a I have how much? For a I have 12. And then for b I have 4 here. I'll write b here. So here 13 plus 4 and 13 plus 12. So 13 plus 4 would be 17, right? So I'll write 17 here. Here 13. Okay. Now from B I have 2 options further, E and F, right? So for E, I'll check for E. For E it is 8. So 17 plus 8. And for F it is 2. So I would consider F, right? So for F it would be 17 plus 2, 18, 19. And from F I have two options further. From F to I, for I it is 9. So 19 plus 9 would be there. And for G, it is 0. So I can reach G directly, and G is the end state which I had to reach, right? So I have reached G, the end state. So now the path cost would be 30. So from S to B, B to F, and F to G. So if I write S plus B plus F plus G, I would get 19. 19 plus 0 here, right? It is 19 only. And considering the path distance, in order to write the path distance, I will make use of these values whichever are specified here. So S to B I have 2, 2 plus B to F is 3, and F to G is also 3. 3 plus 3 is 6. So the path distance would be 6 and the path cost would be 19. So this was about greedy best first search. Now we'll look into the next topic. So now we'll be looking into the A-star search algorithm. So here the graph is given, and as well as the heuristic values are also specified here. So for A-star search, we know f of n is equal to h of n plus g of n. That is, we need to consider this cost as well as the h of n values. So let's start from S. S is the start state and G is the goal which I need to reach. So from S to A, I have 1 here, and S to G I have 10 here. So now calculating the f of n from S to A, I have this g of n is 1 and h of n S to A. So calculating the h of n, I would get A. For A it is 3, right? So 3. I'll get 4 here. So S to A I get 4. And for S to G I get 10 plus G is, for G it is 0. So I get 10. So I'll select this path. Okay. Now next step, from S to A I have reached, and from A I have two options, either to go to B or to C. A to B is 2 and A to C is 1. Now I'll calculate S to C, SAC. For SAC, I have 1 plus 1, that is 2, plus the h of n value for C is 2. That is, I'll have 4 here. And on this side I have SAB. 2 plus 1 is 3. SAB I have 3. Plus for B it is 4. H of n value is 4. 4, 5, 6, 7 is the value. So I'll consider this path as it is the lowest. So next, from S I moved on to A, and from A I went to C. Here 1, here 1. And now from C I have two options, either to go to G or to go to D. So from C to D it is 3 here, and from C to G it is 4. Path cost is 4. Now I'll calculate from S to D. From S to SAC I have reached, right? Now I'll calculate from SACD. Okay. SAACD. Okay. So here 1 plus 1, 2. 2 plus 3. It is 5. Plus for D, h of n value is 6. Got 11. And for S, A, C and G, I get 1 plus 1, 2. 2 plus 4 is 6. And for G, h of n value is 0. So I get 6. So I can conclude that this path is the optimal path. SACG. SAC and G is the optimal path. So this was about A-star search algorithm. So this is one part of second module, that is the informed search strategies. Now we'll look into the second part, that is ML. So ML, here again we have several theory topics which would be asked for 6 to 10 marks. So let's look into them one by one. Firstly, understanding the definition of ML. ML is a sub-branch of AI, we know that. So the textbook definition says that Arthur Samuel stated that ML is a field of study that gives computers to learn without being explicitly programmed. So one textbook definition, and then the normal definition is converting logical and reasoning from experts' knowledge into set of rules and programs in order to construct or model the expert system. So this process comes under machine learning. So here ML model is explicit description of patterns within the data. So here the pattern could be either mathematical equations or the relational diagrams like trees or graphs, or the logical if-else rules, or different clusters. Okay, so this was about ML model. Now we'll look into the relation of ML with other fields. Okay, so firstly we have AI. AI is the broad spectrum under which ML and deep learning come. Okay, so AI is the broader field focused on intelligent agents. We have seen what agents is in the first module, capable of perceiving their environment and making decisions. So depending on the input is taken as sensor, and depending on the input, certain action is performed through the actuator. That is what agent refers to. So it comes under the AI. So ML is the subfield of AI that extracts patterns and regularities from data to make predictions. So this was about ML. Then we have the deep learning. Deep learning is further a sub branch of ML that uses neural networks to model complex patterns and relationship of data. Here neural networks refers to the interconnected layer of neurons, like how we have neurons in our brains. The deep learning is based on that particular theory. So interconnected layers of neurons to process the data and apply activation function to generate the output. We'll be seeing this in depth in the 5th module. So this was about the basic ML intro. Now we'll look into the types of ML. Now we'll look into the labeled data and unlabeled data. So the data set in which each example is paired with corresponding label or output. So whatever the input, whatever you have, the data is defined properly or labeled properly. It falls under labeled data. So in data set of images, each one is associated with label that indicates an object or a category present in the image. So out of 1,000 images, we can classify them as cat, dog and car. So that is what you are labeling the data. It is used in supervised learning. Then coming to unlabeled data, it is data set in which each example is not paired with corresponding data output labels. So that is opposite to this. So in a data set of text or documents, the content of each document is provided, but there are no explicit labels indicating the sentiment of document. So this is used in unsupervised learning. So this was about labeled and unlabeled. Having the brief knowledge of labeled and unlabeled, we'll look into the types of ML. So firstly, we have, there are 4 types majorly: supervised, unsupervised, semi-supervised and reinforcement. Looking into supervised, firstly, we have in supervised, a supervisor component provides labeled data so that model is constructed and generates a test data. So there are 2 stages here. That one is the training and another one is the testing. So based on the labeled data, a training model would be developed, and then a test data would be given as the input, and further the output or the results would be generated. So in supervised learning, there are of 2 types. One is the classification, another one is the regression. So classification is to predict discrete labels from set of finite labels. So the model learns from labeled data and is test on unseen data. So once you train the model, after training the model, you classify them and then you give an input of unseen data to assign the labels to it. So it is used in image recognition, disease diagnosis and all. Now let's look into then the example here. So here I have the labeled data. So these are considered as independent variables. So there are boxes and humans. So through the classification algorithm, the classification algorithm could be decision tree or naive Bayes or artificial neural networks and many others. So through this algorithm, we generate a model. After generating a model, you give an input, that is the new test data. And based on this test data, it will be labeled as a human or a box. So that's what is done here, simply, the simple definition of it. Next, we have the regression model here. So it predicts continuous variables. So it creates a regression tree. In order to generate a regression tree, we make use of regression model. So it predicts continuous variables like price and temperature. Model learns from a fit of line or function, that is through linear regression. So predicting product sales based on weekly data or monthly data, these come under the continuous variables, right? So we make use of regression model here. So the algorithm used here is linear regression, polynomial regression, and so on. Now looking into the unsupervised part. So in unsupervised, it is learning without the labeled data, that is unlabeled data. The model identifies patterns and relationships in the data. So firstly, we have clustering. So clustering is group object based on the attributes into disjoint clusters. So you took the unlabeled data which comprised boxes and humans, and then through the clustering algorithms, it was further classified or divided or clustered into 2 parts. That is one which has humans, that is similarities match here, and then on this side we have clustered to where all the boxes are kept. So this was about clustering. Then we have semi-supervised. So in semi-supervised, we have it is combination of labeled and unlabeled. So here here the unlabeled and labeled data is taken. So application is pseudo labeling is done, oftenly used to combine labeled and unlabeled data set for the learning. Then we have the reinforcement, that is agent interacts with environment, receiving rewards and penalties based on its action. So each and every time the agent generates an action, a reward would be awarded, a reward would be given to it. So goal is to maximize the cumulative rewards over the time. So if the rewards are more over the time, that means whatever the process or the operation was expected to be done has been successfully completed quick in a certain time is what it refers. So it is an approach which involves trial and error, learning from the actions and their consequences. So it is used in game playing and robotics and all. Then we have they can ask the applications of ML. It could be used in image processing, data science, medicine, natural language processing, telecommunication, banking, business, gaming, and many others. Then we have the challenges of ML. So if the problems are not proposed clearly, that is ill-posed problems, it could lead to challenges. Then we have huge data. When the data set is of large quantity, it again creates a problem. Then the complexity of algorithms. The algorithms being used here are very complex. Then we have the bias variance, that is underfitting or overfitting condition can also happen here. Next we have the ML process. So firstly we understand the business, then understand the data, then we perform the pre-processing, then we have the modeling, and then the model is evaluated, and then once evaluation is done, the deployment of model is done here. Let's move on to the next topic. Here we have from the introduction to data topic, we have big data. So big data is large volume of data. So the characteristics of big data comprises of 6 V's. So the first one is volume, that is volume is stored in petabytes or exabytes. Then we have the velocity, that is fast arrival of speed. Then we have the veracity, that is confirming of facts and believability. Then the variety, here the data could be graph or video or audio map, anything. And then the validity, that is accuracy of data. The data which I have obtained need to be accurate enough to perform the further operations. Then we have the values here, that is value of data which is extracted. Further, the types of data we have structured data, that is when the data is organized properly, it falls under structured data. Here we have the record data which is stored in a matrix. Here the rows are called as records and columns are called as fields. Then we have the graphical data. An example to it would be the web pages. Then we have the data matrix, in which the numeric attributes or the vectors or points or the dimensional space could be stored. Then we have the unstructured data. So in unstructured data, we have video games, images, programs, blog, text, documents, or 80% of the organizational data falls under the unstructured data. Then moving on, we have the semi-structured data. Here we have XML data, RSS feed, and hierarchical records. Then the last topic by big data analytics. So big data analytics assist business organizations to take the decisions depending on the analysis which they have performed. Data analysis is activity that takes the data and generates useful insights and the information required for the companies. So types of data analytics, we have a descriptive, that is here we are describing the entire process or whatever the problem is. Then we have the diagnostic. So in this a solution to the problem would be addressed. Then we have the predictive. So depending on the data and the analytics, the further trends could be predicted here. And then the prescribe. So depending on the predictions or the diagnosis, we can say that if the company is in loss or profit, certain prescriptive measures could be given. So that is what prescriptive data analytics refers to. Moving on, we have the binning techniques. So this is the problem. Consider following set. The set comprises of all these values. Apply various binning techniques. So here we have 3 binning techniques. First one is smoothing by means. So the next one is we have smoothing by bin medium, that is to replace the value here. And then we have smoothing by the bin boundaries here, that is we replace the closest bin boundary here. So starting, let's write the solution first. So by equal frequency bin method, data can be distributed across the bin. Let's assume that the bin size is 3. Okay, so bin 1 could be written as 12, 14 and 19. Bin 2 can be written as 22, 24 and 26. B1, B2 and B3. Then we have B3 as 28, 30. Here we have 28 also. 28, 31 and 34. So these are the bin values. By the first method, I can write bin 1 as, by smoothing this I get the value as 15, 15, 15, and for this, considering the mean here, for 12, 14 and 19 I get 15, so I wrote 15 directly, and for 22, 24 and 26 I get 24. Then for bin 3 I get 28, 31 and 34, 31, 31 and 31. Using the bin boundaries method, so I can get for 12, 14 and 19, I can get 12, 12 and 19, that is for bin 1, and for bin 2 I can write 24, it was 24, 22, 24 and 26, so I can write 22, 22 and 26, and bin 3 could be 28, 34 and 34, because this is the closest one, right? And here this is the closest one. So that's how bin boundaries is done. So from here on, this is the end of theory topic. Now we have only the problems here in the second module. So the first one we have is, so this is a set of data, the values are given here. We need to find mean, median, mode, range, standard deviation and the variance here. So in order to find mean, I hope it is very easy. Sum of all these divided by the number of values present here. So we can get 17.5 directly. In order to calculate the median, that is the middle value of the entire data, I will consider n plus 1 by 2. Okay. So here n value is 6. So 6 plus 1 by 2 is 7. 7 divided by 2 is 3.5. So value of 3.5, fifth item would be considered. 3.5th item is not present here. It would be in between 3 and 4, right? So I will consider 3 and 4th item and divide it by 2. So 15 plus 20. 15 plus 20 divided by 2, I get 17.5. One major rule before solving all these is to arrange the data in ascending order. Okay. So assuming that the data is here, I have taken the data in ascending order only. That's why I have directly calculated it. If not, first step would be to do this. Then we have mode. Mode is the number or the data which has occurred most number of times. It has high frequency. So here there is no data which is repeated twice, thrice or n number of times. Then coming to range. Range is the maximum versus the minimum. I get 30 minus 5 is 25. Then comes the standard deviation. In order to calculate the sigma, we can make use of calculator. So that is, I'll show you how to do it. Mode. In mode we select statistics, that is 3. And in statistics we select 1 minus var, and then here we enter the data 5, 10, 15, 20 and 30, 25 and 30. So 5, 10, 15, 20, 25 and 30. The data is entered. Once the data is entered, press AC. Now press shift and press stat 1. Now here select 4 var and then select 4 again SX. So you get 9.3541. So even if you calculate it using the normal, the traditional formula, you get the same 9.35. So sigma is equal to summation I is equal to 1 to n x minus x bar whole square by n minus 1. So this is the formula for standard deviation. Instead of substituting the value here, directly calculate it using the calci. Then for variance, it is the square of standard deviation. So 9.35 square I get 87.5. Then we have the 5-point summary. 5-point summary comprises of the median and then the interquartile range. Interquartile range, in that I have Q1 and Q3. So 1, 2 and 3. Then I have the semi-quartile range and then the box plot. So drawing all these, formulating all these three would come under 5-point summary. So the data would be given. I need to firstly find the mean here. That is the, I need to find the median here. That is the middle value. Middle value is considered as Q2. Then followed by that, I will form two sections here, right? In this section, whichever is the middle value would be the Q1, and in this section, whichever is the middle value would be the Q3. Q1 and Q3 is done. Finding the range now, that is Q3 minus Q1 interquartile range, I get 3, that is 7 minus 4, I get 3. Then I have semi interquartile range, that is 3 by 2, whatever I've got here by 2, I get 1.5. Now I need to represent it using the box plot. So from 8 to 2 I have the data, so put dots there, and at 4 Q1 starts, and at 7 Q3 ends. So put lines here, and then at 5 there is Q2. So put a box from 4, 5 and 7. So this was about box plot. Then skewness formula need to be remembered. This may not be asked, I'm not sure about it. It was not asked in internals. So then we have kurtosis also. So kurtosis also, this is the formula. Then we have covariance and correlation. So in order to find the correlation, we need to find the covariance first. So formula of covariance is 1 by n summation I is equal to 1 to n xi minus e to the e of x into yi minus e of y. So here e of x is the mean of x and e of y is the mean of y. So x and y values would be given. Find the mean of them and then write this formula. So again you can make use of calci here. So write an equation, write the standard equation, that is here xi minus e of x. E of x is constant, that is 13.5, whereas xi value would vary. x1 would be 10, x2 would be 12, x3 would be 14 and x4 would be 18. Similarly 10 minus 13.5 into 40 minus 44 plus again 12 minus 13.5 into 48 minus 44, it will continue till n value reaches, till it reaches 4. Instead you can make use of calci. You can write the standard equation, that is x minus, here I have e of x value as 13.5, so 13.5 into, again I'll write y minus I'll write 44 here. I'll solve this. So first I'll enter the x value, that is 10, and the y value, that is 40. So I get 14. Write 14 here first. Okay, 1 by 4 you keep it outside. Inside the bracket write 14 here first. Next I have 12 and 18. So 12 and 48, sorry. I write 48. I get minus 6. So minus 6 is entered here. Then again 14 and 56. So I get 6. So 6 is entered here. Next I have 18 and 32. 18 and 32. So I get minus 54. Minus 54 is entered. So perform the addition of all these. You get the final value, correlation, covariance. Once the covariance value is calculated, you can find the correlation, that is covariance of xy by sigma x and sigma y. We have previously seen how to find the standard deviation in the previous question, right? Similarly, make use of the features available in calci. You can easily calculate sigma x and sigma y, and then divided you get the correlation value. So this was about correlation and covariance. In case if they ask us the visualization part of the data, we can they can give bar chart or pie chart or histogram, dot plot, box plot, stem and leaf chart or line chart. The data would be given here. Two variables would be given, x and y. So constructing a bar plot, one would be taken as x and the other one would be taken as y, and depending on the value we plot it. We make different separate boxes. And then for pie chart we calculate the sum, and then we formulate for each one. That is for 4.2 we find the sum of all this. Firstly we get 60, right? So 4.2 by 60 into 100, that is 7%. So out of 100% of a pie chart, 7% would be allotted to the 4.2. When age is 1, the weight 4.2. Okay. Then we have histogram, that is continuation of the difference between bar plot and histogram is here you create separate boxes, whereas here it is continued. Okay. Then box plot, we have seen it in the previous question, how to calculate the box plot. And the dot plot also, it's similar. Create dots here on the points and then put different dots or lines here. And then coming to the sixth one we have is stem and leaf. So suppose the values are 4.2, 4.5, 4.7 and all these. So in order to calculate the stem and leaf plot, before decimal, whatever is there, 4, 5, 6, 6, 7, 7, 7, 8. So 4, 5, 6, 7, 8 are common. I'll write them in stem part. After that, whatever is there, that will fall under the leaf part. So here I have 4.2, 4.5 and 4.7. So it will be 2, 5, 7 here. So that's how we write for stem. That's how we write for stem plot and leaf plot. And for line chart, it is the simple. for this extension of this only, you connect the dots, you get the line chart. Next we have the Gaussian elimination method. So we need to solve the given variables using Gaussian elimination method. Our first step would be to write the A is to B matrix. So this would comprise of A values would be on whatever is there on the LHS. So 2, 1 and 4. All the coefficients of x, y and z. 2, 1 and 4 here. And then 4, 11 and minus 1 here. And then 8, minus 3 and 2 here. And on B part, whatever is there on the RHS would be written. So 12, 33 and 20. So my main aim here is to convert the upper triangular matrix, to get this matrix in the form of upper triangular matrix. That is, this part should be converted to 0. That is my main motto. If you look in YouTube, there are they complicated, but then understanding it in a pretty simple way, you need to make these three values 0. That's it. Once these three values are 0, I'll explain you the next step. Okay, so first I'll get this value as 0. So this is row 1, this is row 2 and this is row 3. So what I'll do, row 2, I'll perform an operation. Row 2 needs to be updated such that R2 minus 2 times R1. So when I multiply 2 here, 2 here, 2 here, 4 minus 2 into 2 is 0. So here I'll get 0. So I'll write the updated matrix here. After performing the operation, I'll get upper part would be the same. And here I would get 4 minus 2 into 2, that is 0. So I'll write 0 here. Next, here I have 11. So 11 minus 2 into 1. So 11 minus 2 into 1, I get 9. So I'll write 9 here. 12. That is 9. So I'll write 9 here again. Now I'll write this part as it is because I've performed operation only on R2. So I'll write this as it is, 8 minus 3, 2 and 20 here. Now my next operation would be R3, writing R3 as R3 is equal to R3 minus 4 times R1. So writing the updated matrix now, above it will be the same 2, 1, 4, 12. Here also it will be the same 0, 9, minus 9 and 9 here. Here it would be 8 minus 4 times of 2, that is 0. So I'll write 0 here. Here minus 3 minus 4 times of 1, I would get minus 7. Then I get 14. Minus 14 here. And then on this side, here I have 20 minus 4 into 12. I get minus 28 here. So these are the values I've got. So my aim was to get this particular, these particular values as 0. 0, 0 is obtained. Now here minus 7, I need to convert it to 0. So for this, what I'll do, I'll write R3 as 9 times R3 minus 7 times R2. So if I write the matrix, I'll get 2, 1, 4 and 12 as it is. Here also 0, 9, minus 9 and 9 here as it is. Here 0, 0 would be there. Here I'll get 0. That's I'll explain you. 9 into minus 7 minus 7 into R2 value is minus 9. So 9 into minus 7 and 9 into minus 7 I get 0. And here I get 9 into minus 14 minus 9 into 9, that is minus 189. And so once I've obtained this, all these three, the upper triangular matrix, this part as 0, my next step would be to consider the last row. Consider the last row, we get minus 189 is equal to minus 189. Here, this row was for z, right? This was for y and this was for x. So I'll write z here. So I get z is equal to 1. If I cancel these two, minus 189, minus 189. Now I'll consider the second row. I get 0x plus 9y minus 9z is equal to 9 here, right? Now z value I know it is 1, so I'll write 1 here. So send this 9 that side. So y is equal to 18 by 9. 9 ones are 9 twos are, y is equal to 2. I get 2 here. Now considering the first row, I get 2x plus 1y plus 4z is equal to 12. Y value I know it is 2, so 2 here. And 4 z value I know it is 1, so 1 here. 2 plus 4 is 6. So 12 minus 6 is 6, and here I have 2x, so x is equal to 3. I have obtained the required values, that is z value, y value and x value. So this was about Gauss elimination. So for the main aim is to convert these three, the lower part as 0. Suppose here they have given 3 equations. If they have given 2 equations, then my matrix would be of the form x, y, z, w, and here 1 and 2, some coefficient. In this case, you need to convert this as 0, this z as 0. So that's about Gaussian elimination method. Now we'll look into the LU decomposition method. So for this, LU refers to A is equal to, we need to write it in this form, the output in this form, LU, where L is the lower triangular matrix and U is the upper triangular matrix. So from the given matrix, we need to convert it into that particular form. So starting, this is the matrix they have given. I'll multiply it with the identity matrix. So 1 0 0, 0 1 0 and 0 0 1. So this is the identity matrix, right? So my aim is to apply matrix operations and reduce these two as lower triangular matrix and upper triangular matrix. Lower triangular matrix means this part should be 0. That is what they have said in the that's what we have seen in the previous question, right? Lower triangular matrix. Upper triangular matrix means this part, instead of 0, there has to be some value in it. So we need to perform operations such that both the changes happen simultaneously. So selection of the operations is pretty important here. Let me start from the R2 operation. R2, you can write it as R2 minus 2 times R1. So here I'll get 213 as it is. In place of 4, I get 4 minus 2 times of 2. I get 0. And then here 3 minus 2 times of 1. 3 minus 2 is 1. So I'll write 1 here. And then 10 minus 2 times of 3. 3 2s are 6. 6 minus 10. 10 minus 6 is 4. So I'll write 4 here. So R3 would be as it is, 2, 4 and 17. I am done with this part. Now I'll look into the identity part. In order to change this value, 100, I'll write it here. And in order to change this value, I'll write, this is I'll consider it as L21. Okay. So for L21 operation, I'll take R21 by R11. R21 here is R21, A21 or R21, anything, is 4 by 2. Right, 4 by 2. So 4 by 2 is 2. So from 0, I have changed the value to 2. Right. Then I can write 1 and 0 as it is. And below also I'll write 0, 0, 1 as it is. My aim was to get here zeros and get here non-zeros. So we are done with the first variable. We have 2 more left. In the second operation, I'll write R3 as R3 minus 2 by 2 R1. So writing for this, I'll write the first one as it is, second row also as it is. For the third row, I'll write R3 is 2 here, 2 minus 2 by 2 is 1 and R1 is 2 here. So I'll get 0 here. Next I have 4 minus 2 by 2 of 4 minus 2 by 2 of 1. That is 3 here. I get 3 here. And then I have 17 minus 3. I get 14. 16, 17, 14 here. So I am done with changing the value of second number here. And on this side, I have 1, 0, 0, 2, 1, 0. I need to change the value of this part. This is L31. Okay. So for L31, I can write it is A31 R31 by R11. R31 is 2, and then R11 is also 2. So I get 1 here. So I got 1 here, 0 as it is and 1 as it is. So I have changed this and this. Now these two are remaining. So I'll perform next operation. I'll write R3 is equal to R3 minus 3 times R1. So here I'll get R3 is 0 minus, so 0 minus 3 times 0, I get 0 here. So I write 213 0, 1, 4, and here 0. Next I have 3 here. So 3 minus 3 times 1, again 0 here. And then here I have 14 minus 3 times 4 here. 14 minus 3 times 4. 2 here. So I am done with changing these values. I have obtained the lower triangular matrix. And on this side I need to get upper triangular matrix. So I'll write 1 0 0 2 1 0 here. 1. This part I need to change. This part, this is L3. In order to write value for this, I'll consider L32, that is, I'll consider R32 by R22. R32 value is 3, R22 value is 1, so I get 3 here. So I'll write 3 here, and here I'll write 1 as it is. So my aim was to get this as lower triangular matrix and this as upper triangular matrix. I have obtained both. So they can ask these questions, these type of questions. So it is easy if they have given only 4 values here, 2:2 matrix, then it will be pretty easy to solve. Next topic we have is principal component analysis. In principal component analysis, we try to reduce the dimension. So the higher dimension data to the lower dimensional data, the reduction is done here. In order to perform this, we make use of covariance, eigenvalues, and eigenvector. So this is the question they have given. 4, 8, 13, and 7, the values are given here. We found the mean first, and then we identify the number of features here. Here there are x and y, 2 values are there, right? So 2 features, and number of samples given for each is 1, 2, 3, 4. 4 values are given. So I compute this table firstly, which comprises of x, y, x minus x bar, y minus y bar, x minus x bar whole square, y minus y bar whole square, x minus x bar into y minus y bar. I perform all the operations, find out the values. Then I draw this matrix which comprises of x and y this side, x and y this side. And here I'll be computing the covariance. So covariance of xx, covariance of xy, covariance of yx, and covariance of yy. By the obtained values, I'll be finding all these and then fill the value in the covariance matrix. Now from here I'll be finding the eigenvalues, that is determinant of s minus lambda I. S is the value which I had obtained here, I wrote it, minus lambda times I is the identity matrix I have written. So next I'll multiply this. So I get 14 and minus 11 here, minus 11 and 23 here. This lambda would be multiplied inside, so I get lambda 0, 0 lambda. Now perform the subtraction operation. So 14 minus lambda, minus 11 minus 0, minus 11 minus 0, 23 minus lambda. So solving this, I get lambda 1 and lambda 2 values. So solving the quadratic equation through calci, I can easily get the lambda 1 and lambda 2 values. So once these eigenvalues are obtained, for each lambda I need to perform two times substitution. So first for lambda 1 I'll consider u1 and u2 here. So I'll substitute the lambda value, then I found the result, multiply it with u, so I get one equation, right? So this equation I send u2 to the other side. Okay, so if I send the u2 to the other side, I take it as t here, and then I get u1 and u2 values here, and this was for lambda 1, and then I normalize it. So this is the normalization procedure. Then I move on to the lambda 2, considering the lambda 2. So again perform the same operation. Now step 5 is to derive the new data set. So P1, P11, P12, P13, and P14. So all the values which I previously obtained are updated here in this. So in the matrix, in the graph, I'll consider the new points and mark them as E1, E2, E3, E4, E1, E2, sorry. And then from E1, E2, I find the X and Y values. So this was about the principal PCA topic. I would suggest that if you get this question, just skip it because it's pretty lengthy and time consuming. So this was about PCA. Next now we'll be looking into the probability distributions. So under continuous probability distribution, we have 3 types. So the first one is normal distribution. So normal distribution has the bell curved shape graph, right? So we have studied this in our 4th sem. So the same formula, z is equal to x minus mu by sigma. Here instead of z, they have taken as sigma square. They have taken x minus mu by square by 2 sigma square. So this is the formula for normal distribution. In rectangular distribution, we have P is equal to capital X is equal to small x, where x, if it ranges between A and B, then 1 minus B by A, else it is 0. Then in exponential, we know the exponential formula, lambda e power x into e power minus lambda x. Yeah, this formula we have studied in 4th sem, 0. Coming to the discrete probability distribution part, we have binomial, that is b of x is equal to n c x p of x into q n minus x, and then for Poisson we have e to the power minus lambda x into x. Here lambda is the mean, mu p. Then we have Bernoulli's. So Bernoulli's formula, we know q is equal to 1 minus p if k is equal to 0. If k is equal to 1, then it's just p. Then we have the hypothesis topic. So hypothesis is assumption about the outcome or existing belief that researcher wants to test. So in hypothesis, we have null hypothesis and alternating hypothesis. Null hypothesis is H0 and alternative hypothesis is H1. So in null hypothesis, we have the existing beliefs. So in null hypothesis, we have existing belief. So there's no difference like after performing the hypothesis also. In alternative hypothesis, the researcher claims whatever he or she wants to establish. So there is an effect or difference in this hypothesis. Then we have types of hypothesis test. In that we have parametric and the non-parametric ones. Parametric ones are the based on parameters, like we can make use of mean or standard deviation. We assume that the data follows a specific distribution. So on the basis of distribution, this test would be performed. Then we have the non-parametric test. In this, we don't have any specific distribution, so it is independent of that. Then we have the statistical test here. So then we have the statistical test. So we perform various operations, statistical operations in order to test. And we have the p-value here. So like assuming that the null hypothesis is true, we perform operations here. Then we have error in hypothesis testing. So we know that we have studied this in 4th sem, right? So type 1 error and type 2 error. Type 1 error is false, the hypothesis is false, and on the other side it is positive. Here it is false and negative. So then we have confidence levels. So confidence level is, so below certain point, if the probability comes, then that is not accepted. That's what we have seen in confidence level, right? Then we have different types of hypothesis test here. Z hypothesis test when the data is large, and then the T hypothesis test which is used to compare smaller data, and then chi-square hypothesis test is observed frequency and estimated frequency values. So this part could be asked in the theoretical topics. They can ask us to define these, and even here also they can give us simple values and expect us to answer, but probably these won't be asked because you have big chunk of problems here, serious ones, so those would be asked. So I have tried covering all the topics of 4th module, of all the topics of 2nd module, whichever is important. So share it with your friends. If you have any doubts, do let me know in the comments, and stay tuned to my channel. I'll be uploading 3rd module, 4th module and 5th module also. So thank you.